by the end of the first topic, okay, by the end of the first topic, these are the outlined objectives that you as a student must know, okay? You must know the scientific method there, classification of matter, all this until we have naming of simple compounds, ionic compounds, and binary molecules, okay? But specifically for today's lesson, we'll focus on these two things here, these two things that are outlined here, okay? So the first thing is we're going to look at the scientific method. We're going to look at the classification of matter, which I know you did in grade 12, okay? But we're just going to quickly revise it. We'll differentiate a chemical change from a physical change, and then we'll talk about the extensive and the intensive properties, okay? And then now we are going to focus on the units of measurements, okay? So we're going to introduce these units of measurements in today's class. We'll talk a bit about temperature and how to convert the units of temperature, which is just the Kelvin, the degree, and the Fahrenheit, okay? So we have three there. So let's begin. So what is chemistry, okay? So this is simple. We all know that chemistry, what is just simply the study of matter and the changes that same matter undergoes, right? That's chemistry. So that's how you define it. You say chemistry is simply the study of matter and the changes that it undergoes. Okay. For example, when you cook something, okay, it means that state of matter for the food that is uncooked that's changed into something else that you can be able to eat. So the study of those changes, okay, is what we know as chemistry. And then this same chemistry can be used in a lot of things that we do every day. Okay. For example, for the car to move, there's an aspect of chemistry there. Okay. So in the fuel burns there, you have an energy in form of the fuel that is changing, okay, to electrical energy to enable the car to move. So that is all chemistry. For the electricity, for the computers, okay, for you to be able to listen to me in this class, it's all because of this same chemistry. Okay, the batteries that are in the phone, they are all composed or they work by the principle of chemistry. Okay, and then now we can talk about the scientific method. Okay, so what is the scientific method? It's just simply an approach that the scientists use, okay, in order to discover or to find out something. Okay, so specifically, I'll put the definition here on top. I'm saying this scientific method is just a systematic, okay, it's a systematic approach to research that has mainly 5 steps. Okay, so different books and literatures have maybe 6 or some others are 4. Okay, but the main ones we can say that they are 5 steps. Okay, so what do you do in this scientific method? Okay, so we have 5 steps. The first one is what we call as observation, and then from the observation, once you observe, I've forgotten to put one here. You need to ask yourself a question. Okay, you need to ask yourself a question, and then after that question, in trying to answer it, you create what is known as an hypothesis, which is this thing here. Okay, and then the next step now will be to do an experiment trying to prove this hypothesis that you had. And then after the experiments, of course, you have the results, and then you can analyze your results, and then you conclude. Okay, so that's simply what the scientific method is. Okay, so now let's go over each one of these. Okay, so I was saying we have these 5 steps that we have in the scientific method. Okay, the first one is the observation. Then you ask yourself a question. After you ask yourself a question, I said you create what we call as the hypothesis. And then after creating that hypothesis, you do an experiment, you analyze, you collect your results, and then you conclude, right? Okay, so I'll give an example now of the scientific method. So for example, you want to toast bread, right? You want to toast bread. You get that bread, you put it in the toaster, okay? And then you observe that the toaster is not toasting the bread, okay? The bread is not getting toasted. So your question now will be, why is this toaster not toasting my bread, okay? So you've made the observation that the toaster is not toasting the bread, right? Then the second thing that you do is that, why won't this toaster toast my bread? That's the question, okay? And then from this question now, you come up with a hypothesis. So a hypothesis just, you are trying to get an explanation to explain why this toaster is not toasting the bread. Okay, so the hypothesis that you can make, one of them is maybe the socket there, the outlet where you're plugging in the toaster is broken or it's damaged, it's not working. So that can be your hypothesis. Or you can also use another hypothesis. You can say maybe the wires, okay, maybe you have broken wire somewhere, wonder the toaster is not working. So all those are hypotheses. So you can just pick one. So in this case, let me pick maybe the socket is broken. Okay, so that's your hypothesis. You're trying to explain why the toaster is not working. Okay, and then you make what we call as a prediction. So if I plug this toaster into another socket, okay, then will the toaster be able to toast that bread, or it won't still work, right? So that's the prediction. Then you carry out the experiment. Okay, so you test for the prediction, which is the experiment part here. So you get that toaster with your bread, you plug it into another socket. Okay, you plug it into another socket, okay, and then you observe what will happen. So you plug into that socket, and then you see that the toaster, it's either it works or it doesn't work. Okay, so those will be your results. So if your toaster works when you plug it into the other socket, then it means that the hypothesis was true. But if you plug the toaster into another socket and then it does not work again, it means the hypothesis that you had made at first turns out not to be true. Okay, so you can conclude in those ends. Okay, so here I have two sets of results. The first one, if the toaster works, it means the bread will get toasted, right? So meaning that the hypothesis that you made there was correct. But if the bread won't still be toasted, then it means that the hypothesis that you said that socket was not working is false. Okay, it will not work. Okay, so that's those are our results, and then from there now we can have our conclusions. Okay, our conclusions. So if it works, we can say, oh, all right. So it means that other socket, we need to fix it. Okay. Then if it does not work, then you'll try to check for another fault within that toaster, maybe a broken wire or something. Okay, so that's the scientific method. So in simple terms, it's what is here, okay, on this screen here. So you always follow these steps when you're doing the scientific method, and make sure you know what we do in each of these steps here. Okay, so I've added notes for you to read. That was just me trying to explain. So when I upload the notes on Drive, you can try to read and to know more. Okay, so this is observation. You do the after the observation, you ask yourself a question, then you come up with a hypothesis. Okay, then you do the experiments, you have your results, you analyze them, and then you conclude. Okay, so conclusion is the third step there. Okay, and then from there we move on. This was another example that I added. We move on to what we call as a theory and a law. Okay, a theory and a law. So what is a theory? So a theory is just a tested model that explains a body of facts. Okay, a tested model that explains a body of facts, we call it as a theory. And then a scientific law is just a statement that summarizes the results of the observation. Okay, so the theory and the scientific law, they differ in that, okay, in that the scientific law only describes what has happened, okay, only describes what has happened without trying to explain it. But a theory will describe what has happened and it will explain it. So in the case of the example for the toaster, okay, the toaster was not working. And then we had the hypothesis and then we tested it and we see that if we plug it into another socket, it works. It means the theory there will say that, okay, once I tested this started happening, okay? But if it's a scientific law, okay, it will just say the toaster started working. You get the difference, right? So the theory tries to explain what it has stated, okay? And then the scientific law just states. So it's very much important to know the difference between the theory and the scientific law. Yeah, and I've added the difference here at the bottom here. So you can read it through. And then we move on to classification of matter, which is a very easy concept, right? Okay. So classification of matter simply means that what? We're just classifying matter either as the solids, the liquids, the gases, and plasma. Okay. So we start by defining what matter is. So what is matter? Okay. We all know that matter is just anything that occupies space and has mass. That's what we call as our matter. Okay. And then this matter can be classified into various things. Okay. So so we are on the classification of matter. We're saying it can be classified into different things. Okay, so it would depend whether that matter is uniform or it's not. So if your matter is uniform, okay, if your matter is uniform here, I was asking a question: is the matter uniform throughout? Okay, if your answer is yes, then it means that matter will be called homogeneous. Okay, and if your answer to this question is it uniform is no, then it means that matter will be called what? Heterogeneous. Okay, and then if it's heterogeneous, okay, then it will just be the heterogeneous meter. But if it's homogeneous, then it means that you can continue dividing it, okay, or classifying it into particular classes, right? Okay, so if it's homogeneous here, you can ask yourself, does it have a variable composition? Okay, meaning is it made of one or two things? Okay, if your answer is yes and it's homogeneous, then it means that's the homogeneous mixture of the solution, right? You are getting two liquids that have the same densities, and then you are mixing them. So you won't be able to differentiate which one is liquid A and which one is B because they are homogeneous. Okay, and then if your answer to does it have a variable composition is no, then it means that that matter is a pure substance. Okay, it contains only one substance. Okay, and then if it can be separated, then we'll say that's a pure compound. Okay, and if it cannot, we'll say that is an element. And these elements are the ones that we found on the periodic table. Okay, so this is the classification of matter. This is the same thing that I was explaining. Okay, the mixtures, we have heterogeneous mixtures, and then we have homogeneous mixtures. Okay, so homogeneous will be even mixed like everywhere. It will just look like it's the same thing. But heterogeneous mixer, okay, it will have different composition. You'll be able to tell. For example, if you mix cooking oil and you mix it with water, you'll be able to tell that water ends here and then the cooking oil begins here, right? Okay, so that's a heterogeneous mixture. Okay, and then we continue. this here was still explaining about homogeneous mixture and heterogeneous mixtures. Okay, and then these are notes I was trying to illustrate, but I like to explain with diagrams. Okay, and then now we can talk about the states of matter, which you are very familiar with, right? Okay, so how many states of matter do we have? We know we have 4. So the first one is just a solid. Then we have a liquid, we have a gas, and then finally we have plasma. Okay, so example of a solid, we can say what? Okay, so example of this solid, we can say a stone, a solid, and then say water. Okay, whose phone is that? Okay. Okay, and then a liquid, I was saying you can put the example was water, okay, because we know water is a liquid. A gas, you can say oxygen, and then plasma. Okay, plasma. What is an example of plasma? Okay, so lightning is an example of plasma. Okay, so lightning has it's made up of positive charges and negative charges that are brought together. Okay, so that's lightning there is an example of plasma. Okay, so these are the 4 states that we have. Okay, and then we can talk about intensive and extensive properties. Okay, so what are intensive properties? What are extensive properties? Okay, so intensive properties. Okay, intensive properties are properties that do not depend on the amount of matter that is present in a sample. Okay, for example, the temperature. Okay, the temperature does not depend on the amount of matter that is in a sample. Okay, and even the boiling point. So, for example, if I just get water in a pot, okay, and then I put again water in a drum, okay, and then I start heating them, the boiling point for both those water for the water in the pot and for the water in the drum will still be what 100 degrees Celsius. So it doesn't depend on the amount of matter that is present. That is what we call as the intensive properties. Okay, whether you have a lot of water or just little water, the boiling point will always remain what 100 degrees Celsius. So it does not depend on the matter. Okay, and then on the opposite here we have what we call as extensive properties. Okay, and these extensive properties, they depend on the amount of matter that is present. Okay, for example, the volume. So if I get a balloon and I try to blow air into that balloon, okay, if I just blow a little of air there, then it will just be a small size, right? But if I continue blowing air into that, it will grow and it will be very big. So the volume would depend on the amount of matter that you are putting in, which is the air in that case. So when you're blowing in the air there, as you are blowing more air, the volume will start increasing, right? Okay. So extensive properties, they depend on the amount of matter. Okay. So examples, we have weight, even length, uh, volume, and then entropy. So entropy is just simply energy. Okay. Energy. The energy that is present will depend on the matter that is present. Okay. So no wonder this time we're experiencing load shedding because there's no water. So meaning the matter has reduced. So the water that comes to pass through those turbines that generate electricity, okay, the water, the pressure has reduced, so you can't produce electricity at the rate that you normally would. Okay, no wonder we have load shedding. So entropy, which is the energy, it depends on the matter of the amount of matter that is present. Okay, and then even the volume there. So these are examples of extensive properties, and then these are examples of intensive properties. So take note and know them. Okay, and then these are the notes for you to read. And then now we can go to the units of measurements. Okay, so before I continue, anyone who has a question? Okay, no question. Okay, so units of measurements. Okay, so this is actually where your lectures will start. You start the lessons. Okay, but my lessons I like to start them from the scientific method. Then I come down like that. Okay, but when you go to university, you actually start from the units of measurements. Okay, so what are the units of measurement, or what is a unit? Okay, so a unit okay, so a unit of measurement, okay, is simply a standardized quantity that is used to express a physical quantity. Okay, so a physical quantity such as length, we have time, we have length, okay, we have mass, okay, we have concentration. All those are physical quantities, something that you can measure physically. Okay, so a unit of measurement is a standardized quantity that is used to express the physical quantity. Okay, for me to know that this sugar that I've bought is 2 kgs, okay, I need to have a unit of measurement. For me to know that this is a 50-centimeter rule, I need to know the unit of measurement of the length, right? Okay, or for me to know that this exam will take such period to complete. Okay, then it means I need the unit of measurement, which is what? Time. Okay, so it's just a standardized quantity that is used to express a physical quantity. Okay, so we have 2 types of these units. Okay, we have what we call as the SI units. Okay, SI units. I'm sure those who attended the physics class, Tutor John was talking about the same units. Okay, so we have SI units and then we have derived units. Okay, so These SI units are the most important units, okay? And they are only 7. And then from those 7 SI units, you'll be able to come up with hundreds of units, okay? A lot of units. And those units that you come up with are what we call as derived units, okay? Why are they called derived? Because they are made from the SI units, okay? So we only have 7 SI units, okay? And then when we start combining these SI units, maybe you get this unit and this unit, you come up with a third unit that we call as a derived units, okay? So it's very important for you to know the 7 base units, okay? Or the 7 SI units, okay? So the first one is the meter, okay? And the meter is used for measuring length, okay? So if we talk about length, the standard unit, okay, will always be the meter. And then when you talk about the kilo, the mass, okay, the mass, it means the units that we use for mass, we know it's kg, right? We're very familiar with the kg. Then time, we use seconds. And then thermodynamic temperature, or just simply temperature, the SI unit for temperature is or are the kelvins, okay? So the degrees Celsius, that's not a base unit, okay? That's not a base unit because you can get the degree Celsius by combining these 7 units here. Okay, and then we have the ampere, which is used to measure electrical current. And then we have the mole, which is very, very important in chemistry because everything that you'll be doing in chemistry will just be zingati moles. I've done this, whatever. Okay, so you really have to familiarize yourself with the mole. And we know that the mole just measures the amount of substance that is. Okay, and then we have the candela, okay, which is not that famous, okay, and it's rarely used. Okay, so the candela is used to measure the luminous intensity, okay, or the light intensity. So these are the 7 SI units, and then from these units we are going to get the derived units. Okay, so let's say for example I get length, okay, and then I divide it by time, which is the seconds. Okay, so you have m per second. Okay, so m per second, we know that it becomes a unit for what? For speed. So we see that you can get 2 base units, and then you come up with the derived units. Okay, so the most important thing is to know these 7 here, because if you're also doing physics, in physics they will even they'll maybe give you the units for speed, and then they ask you to prove if those units are correct, right? So if you don't know the base units, then it means you can't. So you really have to know the base units, which are 7. Okay, so you can swatter them, so you can master them. So there's meter, kilogram, second, Kelvin for temperature, ampere for electric current, the mole for the amount of substance, and then we have the candela for luminous intensity. Okay, and then these are the same base units here. Arrange them in a table, or saying the symbol that is used to represent it, and then the name of the base units that they use, and then the symbol. Okay, so we can go through this, and then all other units, okay, are made from these units. Yes.
The candela is used for what?
For luminous intensity.
Pardon?
For luminous intensity, the light intensity.
Oh, okay, thank you.
Like the brightness. So. Okay, so that's the candela. And then now we have derived units, which are in this table, as you can see. Okay, so it contains a lot of units. So for example, here we have the area. Okay, so we all know that area is found by multiplying length times the length, right? Okay, so L times L, we know that the length is M. So M times M will just give you what? M squared. So under the units here for the length are just M squared because you are multiplying 2 lengths there. Okay, and then the volume, it means you are multiplying 3 lengths there, and you end up getting cubic meters like that. Okay, so you see that all the derived units, they come from the SI units. And then if we talk about the density, okay, if we talk about this density here, it means we're just dividing, okay, the mass over the volume. Okay, so they can, if it was in physics, they can ask you to prove that these are the units for what? For density. But if you don't know the base units, then you can't prove, okay? You can't prove it. So it's very important to know the base unit. So from the kilogram here, which is the mass, and then we are dividing it with the cubic meter, which is the volume, okay? We're able to get what we call as the density. So their units, it means you just divide them the way they are. So the unit of the mass will be on top, and then you divide it by the units of the cubic meter, okay? And then speed, this was the example that I gave. You are just dividing length, you're dividing time, okay? And then you have all these others here that come from the base units. You have your pressure, your acceleration, force, energy, frequency, power, voltage, and your charge, okay? So all these quantities here have units that come from the base units, okay? So I've put a nice table here for you. It's just a matter of mastering them, okay? So you master the symbol that they use, and then you even master the units, okay? If you want, you cannot master these units, but make sure you know those base units, where they're coming from, okay? Because if they tell you to find the density, you know that I'm dividing mass over the volume, which means you can be able to come up with these units here. Okay, and then let's go over some units now. Let's go over some units. So we have mass, okay? And we know that mass is just the amount of matter in an object, okay? And we know that mass is constant everywhere you go. So if mass is constant. Then we have weight, which is a variable, right? When you go to Mars or you go to space, the weight won't be the same because the gravitational force there is different. Okay, so we know that the mass is measured in what? We said the standard units there were kilograms, right? Okay, then weight. Okay, so weight is actually derived from this mass. Okay, so the unit for weight are actually derived units. Okay. And then here I was trying to give an example. Okay, so how do you find the units for weight? So we know that weight is just equals to um, the mass multiplied by the gravitational force, like that. And you know that the gravitational force is just 10, okay, or 9 point something. Okay. Yeah, so here I was trying to give an example here. If, for example, a box has this mass here, which is 4.125 kg, okay, and then they ask you to find the weight of this guy here. So we know that the weight, which is just the force, will be equals to what? Will be equals to mg, okay? Will be equals to mg, and the mass they have given us 4.125 multiplied by the gravitational force, which is 9.8, right? So 9.8, or you can use 10, and then when you multiply these two here, you'll be able to get your weight or your force, okay, which will be just be approximately 40, okay, and then the units for weight are just newtons, okay. But what are actually newtons when you break them down into SI units? Okay, newtons are actually this, okay. So you're multiplying a kg multiplied by the length, and then you're dividing by time squared. That's what a newton is, okay. So they can ask you to prove that actually this newton is equals to this unit here. Okay, so you have to familiarize yourself with that, and then we can talk about volume. Okay, volume, which is very similar to capacity. Okay, which is very similar to capacity. Okay. Okay, so the units that you use to measure volume, okay, we said those cubic meters, right? This guy here, those cubic meters here. Okay, but this cubic meter can actually be changed into other units. Okay? So I've written conversion factors here. Here I was saying 1 milliliter is actually equals to 1 centimeter cubed, and 1 liter is equals to 1,000 cubic centimeters. Okay, so it's very much important to know this conversion factor and that conversion factor there, because they can bring a question, especially when you're dealing with moles. They will bring a question in cubic centimeters. Okay, but for you to carry out those calculations, you always have to convert to what? To liters. Okay, so you have to know this conversion has to be in your head. Okay, so 1 liter is equals to what? Okay, so I was saying 1 liter is actually equals to 1,000 cubic centimeters. Okay, so you need to know this conversion factor here. So it's very important. Okay, and then from the volume, we can talk about the area. Okay, we can talk about the area. We know that area is found by what? Okay, so area is found by multiplying L multiplied by L. We know that this is how we find the area. Okay, so meaning if I have meters and meters, it means the area will just be in cubic meters there. Okay. Okay, so these are the units for area, and actually you can convert them. From this meter here, you can convert to cubic you can convert to squared centimeters or centimeters squared, and you can also convert to millimeter squared. Okay, so this might look strange because I haven't explained the metric system yet. Okay, but when I explain it, you familiarize yourself with how to convert these units of areas. Okay, and then we have density, which is just mass over volume, and we know that the units there will just be what? Okay, so for the mass is kg, and then for the volume we said cubic meters. Okay, so it means the density will just be kg per cubic meters, like that. Okay, so this will be the units for density. Then we can now talk about what we call as prefixes. Okay. Okay, so what are these prefixes? Okay, what are these prefixes? So the prefixes are actually a way to denote multiples or fractions of units. Okay, meaning it's a way of representing a very big number or a very, very small number. Okay, so if for example, they tell you to write 1 million like that. Okay, so 1 million, we know it has 6 zeros like that, right? Okay, so this is a very big number. So you can use these prefixes to actually represent 1 million in a very simple way. Okay, so you can just say, oh, this 1 million is equals to, or is the same as 10 to the power 6. Okay, so this 10 to the power 6 here is a prefix. Okay, it's a prefix because it is an easier way to represent a very big number. Or for example, if I had a very small number like 0.0000001. Okay, so you see that this is a very, very small number, but using prefixes, I can actually represent this as 10 to the power minus 6. Okay, so how am I getting this minus 6 here, and how am I getting that positive 6 here? I'm simply moving the decimal place 6 times. So if the decimal place is here in 1 million, okay, it means I'm moving it 1, 2, 3, 4, 5, 6 times when it comes there, right? Okay, so that's why it is 10 to the power 6. And then even here there, when I move this decimal places 6 times to the right, it means I have a negative. If I move it to the left, it means I have a positive. So here I can move it 1, 2, 3, 4, 5, and then I say 6, and then that will be 10 to the power minus 6. Okay, so these prefixes are just used to denote very big numbers or very small numbers. Okay, and these prefixes are very much useful when you are converting units. Okay, maybe you're converting from meters to milliliters, meters to millimeters. Okay, or from grams to megagrams or kilograms. These prefixes are very much important, and that's why they give us what we call as the metric system. Okay, so this is the metric system here, and each 10 to the power something has been assigned a name and a symbol. Okay, so if I have 10 to the power negative 1, we call that as deci. Okay, 10 to the power minus 2, it's centi. Those centimeter, it means there's a 10 to the power negative 2 somewhere inside there. Okay, power 3, it is a milli. Then we have a micro, we have a nano, we have a pico. Some others say this is pica. We have femto, atto, zepto. Okay, so you can actually read through this. Okay, so these are for the negative numbers or the negative powers. And then for the positive powers, if it's 10 to the power positive 1, we call it as deca. 10 to the power positive 2, that will be hecto. 10 to the power 3 will just be what? Kilo. Then 10 to the power 6, which is actually million, will just be called as mega. Okay. No wonder they are on Facebook when a post which is 1 million, you see they write it as 1M, right? So 1 million, meaning that it's just 10 to the power 6, which is a million. Okay? So you have to familiarize yourself with this. They will help you convert the units. Okay, this is the same thing that I was explaining here. And then it's the same thing here. So during our time, there was actually a song that we used to memorize these things here, the metric system. Okay, so we used to start from this pico here because it's the smallest with the power 12. So we're saying pico, nano, micro, milli, centi, deci, kilo, mega, giga, tera. Okay, so you can actually master that song, and then it will be guiding you. You know that I'm starting with pico, which is to the power negative 12, and then the next one will just be to the power minus 9. So they reduce in threes until they reach at milli, and then the centi will just be minus 2. Then the deci 1, and then you have the meter here. Okay, which will just be 10 to the power 0. Okay, yeah, so you can actually sort that same song. So pick another micro, milli, centi, deci, kilo, mega, giga, tera. If you've known all the metric system, and it will be very easy for you to convert. So if, for example, I'm given let's say two nanometers. Okay, 2 nanometers. They tell me convert these 2 nanometers to meters. So what do I do? Okay, I just replace this n because I know this n is nano, right? Okay, so what is the value of nano? So the value of nano is just 10 to the power minus 9. So it means for me to convert 2 nanometers to meters, I'll just say it's the same as, let me write it here. It's just the same as 2 multiplied by 10 to the power minus 9 meters, like that. Okay, you can see that in place of the nano here, we'll just put what the nano represents to change into meters. Okay, so converting units is as simple as that. If you have the metric system in your head, then it will be very easy. Okay, let me give another example. So if I have 5 micrometers, okay, so if I have 5 micrometers, okay, it means I just have to know the value of micro for me to convert it to meters. Okay, so this is the same as 5 multiplied by 10 to the power minus 6. Okay, because micro is 10 to the power minus 6. You can see it here, right? You can see it here. Yes. Okay. So that's how you do the conversions there. So make sure you know the metric system. And then here I was trying just to convert. You can actually go through this. I was showing the steps here, even here. Okay. And then we talk about temperature. Okay. So what is temperature? Okay. So temperature is just the degree of hotness or coldness of a body or an environment. Okay. And it is usually measured in 3 scales. So we have the degrees Fahrenheit, we have the degrees Celsius, and we have the Kelvin. And we said the Kelvin was what? Was the SI base units, right? Okay. The Kelvin was the SI base units. Okay. So this is the standard unit for temperature. So whenever you are using temperature in chemistry, in physics, you always have to put your units in what? Kelvins. Okay. So these Celsiuses here, they're just used in maybe clinics to take your temperature when you go to the clinic, to the hospital. Okay. Even the Fahrenheit, but the Fahrenheit is not mostly used in Zambia. Okay. But when you go to the USA, there they use Fahrenheit there. You won't find the Celsius in the hospitals. Okay. So that's that. Okay. And then the most important thing about this is that you have to know how to convert from the Fahrenheit to Celsius, okay, and from the Celsius to the Kelvins. Okay, so the first conversion there is how to convert the Fahrenheit to the Celsius. Okay, so you can simply convert this by knowing this formula here that is written on your screen. Okay? There's no other way to convert the Fahrenheit to the Celsius than knowing this formula. Okay, so you have to know this formula. So the formula states that the temperature in degrees is equals to 5/9 multiplied by, in brackets, you put the temperature in Fahrenheit minus 32. Then you'll be able to get your what? Your degrees Celsius, in case you are given the Fahrenheit. So the job here is just to master this formula. So your temperature in degrees Celsius is actually equals to 5/9 multiplied by the temperature in Fahrenheit minus 32. Okay, meaning from this formula we can even make F the subject of the formula, right? In case we are given the Celsius here to convert it to the Fahrenheit, which means we can just make this F the subject of the formula, and then you do the substitution again. So here we have an example here. Okay, so they're saying convert body temperature of 98.6 degrees Celsius, degrees Fahrenheit, I mean, to degrees Celsius. So we just have to use this formula here on top. We know that a Celsius degree is actually equals to the Fahrenheit here minus 32 multiplied by 5/9. This 5/9, you can even put it in front here. Here it was in front. Okay, so it's just the same thing. So 5/9 multiplied by the value that you are given in Fahrenheit minus 32, and then you'll be able to find your degrees. Okay, so this is actually the normal body temperature in Fahrenheit, 98.6 degrees Fahrenheit. That is the normal body temperature. Then when you convert it to degrees, we see that it's just 37, right? 37 degrees Celsius. Okay, so you can actually do the opposite. If you are given Fahrenheit here, when you are given the degrees Celsius and you want to convert to Fahrenheit here, right? So that formula that we had, if we make F the subject of the formula, we end up with this. Okay, so you just simply apply the formula and then you'll be able to find the temperature in Fahrenheit. Okay, so this is an example of a conversion here. They're saying convert the body temperature of 37 to Fahrenheit. Okay, so just use the same formula, but we've made F the subject of the formula now. Okay, so if you do that, you are going to see that you are going to end up with 98.6 degrees Fahrenheit, like that. Okay, so the conversion for the temperature, they're not difficult as long as you know this formula here. You can either know this formula or you can know this formula. Okay, when you're given either one of them, it will be very easy to convert. And then the other conversion that you have to know is the conversion of Celsius to Kelvins, and this here will be it will be the one that you'll be most using in your questions, because I've never seen a question that came with Fahrenheit anyway. Yeah, but it will be Kelvins to Celsius or Celsius to Kelvins. Okay, so this is the formula here that you use actually. So you say the temperature in Kelvins is just equals to the temperature in degrees Celsius plus 273.15. Okay, so this is the formula. You have to know this formula. Meaning when you're given degrees here, you just place them into there and then you add this constant here to get your temperature in Kelvins. Okay, so if I want to convert 30 degrees to Kelvins, it means I'll just put 30 degrees here and then I'll add the 273.17. Okay, and then what I'll get will be my Kelvins here, which you can also round it off to just 3.03 there, Kelvin. And then you can actually do the same. Okay, meaning you make the Celsius as the subject of the formula. Okay, so if we make Celsius the degree Celsius the subject of the formula, we end up with K minus 273.15. Okay, so convert 300 Kelvins to Celsius. You just plug it into this value, the formula I mean, and then you'll be able to find your Celsius degree there. Okay, so a very important note to remember is that the Celsius temperatures or the Fahrenheit temperatures, okay, they have a degree symbol. What do we mean by degree symbol? We mean that got 0 there, like that. So degree Celsius or degree Fahrenheit, like that. Okay. However, the temperature in Kelvins does not have this degree. So for Kelvins, you just write K like that. Then to be Kelvins. Okay. And then we are done with the introduction, and then we can look at the examples, the exam sample questions, okay, on the same concept that we've covered today. Okay. So I'll create another session where we'll just be solving questions on the same concept that we have done. Okay, so here you can see the questions here. I've put them, okay. Okay, so here you can even, we can take an example. They're saying dash is a possible explanation for an observation, okay. So we said anything that tries to explain an observation is called what? A hypothesis. So that the answer there will be the hypothesis. So these questions do come, right? They just look simple like that. So make sure you start knowing them from the very start, okay? And then these are other questions here. They're saying define each of the following terms applied in the scientific method. We have the hypothesis, I've explained what it is, the theory and the law, I've explained what all these are. And then here we have quantities, the units, okay? So here they just brought a table and you are asked to fill it in, okay? So the 7 base units, you have to know them. You can see that they only gave the mass here and the rest you have to put them there, okay? So we know that there's time there, you can put time, you can put mass time, you can put length, you can put moles, okay? All those until they are 7. So you have to know them by heart because you can just bring this table. Then here you put the unit and then the symbol there. Very important, okay? And then the prefixes here, let's see if we can name them. Okay, show our understanding of the matrix prefixes by giving the name of the unit that equals the following. Okay, so we said that what 10 to the power 9 was just what? Okay, 10 to the power 9 was just none. So you have to know those, right? And then 10 to the power minus 15, they are all in that table. So you take a look at them, then you'll be able to name them. So this will be a nanogram. This will be, what is 10 to the power 9? Okay, so if I sing that mica song, we said pica, nano, micro is written like that, like KU, micro milli, then we said centi, deci, kilo, we have mega, pica, nano, micro milli, centi, deci, kilo, mega, giga, tera. Okay, so we said these reduced in 3, right? So pica is just 10 to the power minus 12. Nano is 10 to the power minus 9. This will be minus 6. Mid will be minus 3. And then centi, we said it's minus 2. This will be minus 1. Okay. And then when you come to the kilo here, you'll begin at 3. This will be 6. This will be 9. And then this will be 12. Okay. So it means whatever is coming after tera there, it will be the 15. Okay. Or whatever is coming before the pica here, to be minus 15 like that. Okay. So we see that 10 to the power 9 there is just what? It's just a gigameter. So here the answer will be gigameter. So you have to know that metric system just like that. That's how the questions come. Okay, and then I have other exam questions here. We can try to pass through them when I upload on Drive. And then the conversions of temperature here, convert this guy to Fahrenheit, convert these Fahrenheit to degrees, convert these Kelvins to degrees. I've shown you the formula there that you use. Okay, so you can actually try out these questions when I upload the notes on Drive. And then you send me the solutions, then I can guide you where you need guidance. Okay, and so we are done. So I don't know if you have any questions. Is there any question? Okay, no question. All right, so we are done for today. That's the class. And then the next topic that we'll do in chemistry will be units and measurements, where I'll go deep now to the things that they like examining. Okay, I'll bring questions and then we'll try to solve them. Okay, on units. Okay, so have a blessed night.
Thank you so much.